purpose of this video is to show the compound effect. The compounding effect is when an investment has grown due to reinvesting of the previous returns, the profits of that investment. Here is the page on Investopedia about compound interest. Look at the section that is titled The Effect of Compounding Periods. We will see this is a chart that shows if something has been compounding annually, semi-annually, quarterly, or monthly. So that means within a year's time, have something been invested back into it once, twice, 4 times, or 12 times. Now in this chart, you will see as the years go on, the lighter bar is the biggest. While it's not extremely large over the other ones, but it is still more. And that is how compounding works. It will take your previous investment, it will put it back in, and because you had just a little bit more to put in, it will grow a little bit more. While this video is being made because it's to show the compound effect, it is also in response to some YouTube video about when a person gave his 6-month update on his returns from groundfloor.us. Groundfloor.us is a site that allows people to be able to contribute to lending money to renovators and developers of real estate. Unlike other sites where a person might need thousands of dollars to start off, on Groundfloor, a person can start off with $10. The site will have different loans with various rates and terms. Here is an example of what they might have. They might have a rate of 10% and might have a term of 9.8 months, but no, that's good enough to say 10 months. So the rate is not what you would expect. The reason being is, at least it's not what you can expect at the end of the term. The reason being is because this is the annualized amount. What that means is if this loan had a term of 12 months, then you can expect the 10%. However, since it's annualized, it's best for us to try to convert it into something that would happen monthly. So what can we expect per month? So we have 0.1, which is 10%. We're going to divide it by 12, and per month we will get 0.8333%. So what this means is if you had $100 and for every month you can expect to get 83.333 cents. Obviously there's no 3333 out there for cents. You only get 83 cents pretty much. Usually financial institutions round down when they use percentage, and then when it converts over to cents. Okay, so now let's go and verify if this is actually correct. It should be. So we know at a 10-month period, which would be this loan, that's $8.33. Now we want to take this monthly amount, apply 2 more months. Now add the 10 months to the 2 months, which would be 12 months, and that's $10. And 10% of $100 is $10. So this come up to the correct value. However, once again, this is not our true expectation. So let's round down. You see, as you round down, you lose 4 cents, but still it's close enough for an error margin. Now, let's go back to the purpose of this. So the person wanted 10%. However, he wanted as close to 12 months as possible. The reason being is because, he wanted the full double-digit return, which, it's a very good return, 10%. Not many things could give you 10% on a consistent basis. Now, here is a screenshot of what I had from his video. Let's focus on this last one at the bottom. This one has a 10% return, and it's a 2.6 month term. Now, we're going to just use 3 months for the example. It's easier for me to calculate. So we're going to reuse what we already have, this 83%. Here, let me round down this one. Uh-oh. Nope, that's not working. Stop that. Okay, well, that one is round down. So 3 months, that would be, this is a monthly return. So at 3 months, we can expect $2.49. Now the thing with this is because this loan is a deferred loan, so you will get everything at once. It probably is good enough to use the non-round down version of this. Yeah, sure. At least for our example, we're just going to use the non-round down. So, okay. So supposedly this is now $2.50. You will make off for that one loan. Now, what he wanted was, he wanted a 12-month loan. So he should expect $10. That's 10% for 12 months. But let's say we were able to get, every 3 months, we were able to get a 3-month loan. So that would be 4 loans in which we can make at 10%. All right, so we have the $100 of principal. We have a round down of the expected monthly return. Then you multiply that by 3, that's $2.49. So what should we expect out of 12 months? Now, we can say we can expect this, the return of $2.49 times 4 for the 4 loans, which is $9.96. Well, no. The reason being is because every time when we have a profit from a loan, we will add it back into the principal. So our next loan would be this amount, $102.49, which we can expect $2.55 for profit, which is greater than the $2.49 already. So now we're going to add this back in to the principal. Now loan number 3 would give us 261. No, loan 261. So we now will add the 261 back in. Now the fourth loan we will make 267. Okay, and now this in amount $10.32. Now that is the one that is the actual end of the 12-month period. So you see with a 12 months, if you would have got a 10% at 12 months, you would have had 110. 10% at 3 months, and you keep making them, you will have 32 cents extra. That 32 cents represents 3.2% more profit. Um, this is more than the regular 10% in which you could expect just for the 12 months. And this is the compounding. Now, if this goes out even further, it will make even more money. You will just keep using money that you didn't have to work for to work for you, and it will compound on top of itself. So this was one method that I went through when I was rounding down for what I would expect on a monthly basis. There's certain formulas which is used. Let me start from the top over here. This is 10% every 6 months, so this is annual, semi-annual, and you will have two loans. So you'll say you start off with a 100. This is the 10% divided by the 12 months times the 6, and it's roughly like 5%, right? So your first loan will give you 5%, which is $5, and then your second loan is $10.25, which is still more than just one loan at 12 months, which will only give you 10. Now over here was the one that I was giving the example for, the 4 months. Here you'll see that this has a different rounding. Mine was 249, but here is 25. It's a decent amount of error margin, so it's good enough for the calculation. It's besides, this is just the illustration. It's not a detailed calculation. So you come out with $10.37. Now this is the actual compound formula where P represents your principal, which would be $100. R will represent the rate. The rate in which we would have is the 10%. The N represents the number of periods, the number of loans within that period, at least the number of times which you expect to get money. And for our case, it's the number of loans. So in here, it was 4. Here, this is 1 loan. The 6 is 2. And this T for us is the time period, which is 1. It's gonna periods in the year 1. Our period is 1, but the periods of the year is our loans of the year. So as you see, with 1 loan, you will get back 110. And after 21-year time frame, you can expect $740. Now, if we was to change this to the 4 loans within the year, again, it's another rounding, but it's still good within the error of margin. It's 110.38. And by the year 21, you'll see it's over $55 more than what was there when it was just 1 loan. So this was just the illustration of the compounding effect, that you would want loans that would, with the highest rate in which you can get, but with the lowest term that you can get. Then you will be able to reuse that money quicker to grow faster. 740 versus 798, 95.